Okay, 9.1, maximum and minimum problems. Right, so you can solve calculus to determine maximum and minimum values of displacement, velocity, and acceleration. Now, it says here, example 5, a child is playing with a yo-yo. The yo-yo leaves the child's hand at t equals 0 and travels vertically in a straight line before returning to the child's hand. The distance s meters of the yo-yo from the child's hand after time t seconds is given by this formula. And it's between t's values from 0 to 3. Justify the restriction, part A. Well, looking at this, it's a cubic. Couple of things you should know about a cubic, just like a quadratic, smiley faces and unhappy faces. If it's a negative, if it's positive, first of all, it will slope that way. If it's negative, it will slope that way. Okay, so we're looking at the second one, obviously, because it's negative. We really need to plot this, so we know the shape of what we're looking at. We just need to better plot it. So a couple of things. First thing is obviously the shape of it. It's negative, so we know it's doing this. The second thing is setting s to be 0, obviously, because your axes are going to be looking like this. Your distance and your time going across like that. I'll need that section. And we're going to need to look at where it's crossing, how many times it crosses, etc. So I'm setting s equals 0, so that's the next thing. So I've got 0.6t plus 0.4t squared minus 0.2t cubed is equal to 0. So I'm going to times through by minus 10 and then divide by 2. So minus 5 times through by minus 5 really. So here we go. That becomes a positive, and times it by 10 and then divide by 2 gives you t cubed. That becomes a negative, and times it by 10 divided by 2 is 2t squared. Times it by 10, divide by 2 and change the sign gives you 3t is equal to 0. So that's what it boils down to. T is a common factor, so t open brackets, and you're left with t squared minus 2t minus 3 is equal to 0. And we knew that one of the solutions is going to start here where the yo-yo is thrown up. Okay, so the next thing is to factorize this further. So t brackets, 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 brackets. You could use your calculator at this stage. You've got t, and it's got to be 3 and 1. And this is going to be the negative, and this is going to be positive. So therefore the solutions are, when the distance is at 0, s is 0, you get t is 0, time is 0, time is minus 1, or time is positive 3. So obviously if I continue this back here a bit, not that we should really need it because you can't go back in time, but there we go. So you've got minus 1, you've got 0, 1, 2, 3, and because of the shape of it, and the second thing is obviously setting it equal to when t is 0. So putting back up here, putting t is 0, you can see it crosses there anyway. So that is definitely one crossing point on the y-axis or the s-axis. Okay, and it's looking like this. So it comes down here, minimizes, comes up here, and goes down there like that. So we've got the shape of the curve. It's a cubic, and we'll justify that that's 3, that's 0, and we've got to justify that it's only valid for 0 and 3. So we can say for the right up here that s is equal to 0 at t equals, and obviously we're not going to talk about this because there's no such time as going back and negative, so we're only looking at this section. T is 0 and t equals 3. For t greater than 3, s less than 0. S is a distance. A distance can't be negative. Can't be negative. Okay, and that's good enough justification as to what's going for that for part A, justify the restriction. The next bit, part B, says find the maximum distance of the yo-yo from a child's hand, so it's up here somewhere, and we need to find out where that is. So it's no case of symmetry here, we've got to differentiate it to find the stationary points, one here which we don't need and one here. The stationary points, when you differentiate it, will give you values for t. Once we get our values for t, we shove it back into here and we'll actually find out what the distance is. So that's the next step, is to go ahead and differentiate this. So part B, or you should have called that part A, we end up with S equals, and I'll go back to the beginning, which is there, I can see it there, 0.6t plus 0.4t squared minus 0.2t cubed. Okay, and we're going to find the stationary points by differentiating with respect to t, and you will end up with ds by dt is equal to 0.6 plus 0.8t minus 0.6 t squared. Okay, and then at ds by dt, the gradient, where the gradient is equal to 0, well, I end up with 0 is equal to, and again at this stage here I'm going to times through by 10 and divide through by 2 to give you 3 plus 4, in fact, yeah, too late, 4t minus 3t squared. And I should have times through by minus and ready to factorize. So I end up with 3t squared, not to worry, minus 4t minus 3 equals 0. Okay. Now you've got calculators. You can use the quadratic formula, or, but I'm going to go ahead and solve this on my calculator. Okay, but you could use the quadratic formula. So just bear with me. I always have to teach myself how to use this again. So that AC, right, and it is down here, equations, polynomial 2, and it's degree 2, and I've got 3 of them, press enter. I've got minus 4 of them, negative 4, press enter, and I've got negative 3, press enter. And the first solution says that t equals 2 plus root 13 over 3, or t equals, so that's the positive one. I'm expecting a negative value here for the minimum. Okay, so equals again, and I end up with t minus root 13 over 3. So impossible, it's this one we want to use, so identify it. And therefore I've run out of space below, therefore to get the distance we're going to shove that into this original formula. So to get the distance s, I'm going to put it into there. So 0.6 lots of 2 plus root 13 over 3 plus 0.4 lots of 2 plus root 13 over 3 squared, and then finally minus 0.2 lots of 2 plus root 13 over 3 cubed. So we get an answer. So let me just go back through that. Okay, right, got to get out this mode. So mode 1, back to normal. So all I've got to do now is type that in, use that as an answer. So fraction 2 plus, I should have stored it, but don't worry, root 13, come out, go down, 3 equals, I've stored it as my previous answer, so it is brackets 0.6 times answer, close brackets, it is plus 0.4 times answer squared, close brackets, Okay, I'm just looking at this thing here. Yes, yeah, it's fine, isn't it? That was positive, that's negative, that's fine. Yeah, I'm miles away. And I've got minus brackets 0.2 times by the answer cubed, which it is there, shift cubed, close brackets, and I get my answer as being 1.21 meters to 3 SF. Okay, so that's the greatest height the yo-yo goes above his hand or her hand. Okay, so there it is. That's using maximum and minimum values. That question there. Right, over the page. Oh, it's straight down to the exercise, and there is, or there are, looks like it's just 6 questions. Yeah, 6 questions. Give it a go. Email me any problems, and I'll go over individual questions that you need to, but you must complete everything. Okay, good luck.